I'll be talking about what is Bremmstrahlung radiation and characteristic X-rays. Before going to the Bremmstrahlung, I'll be telling about the characteristic X-rays. So characteristic X-rays are the ones if there is incident electron, the incident electron when it hits the inner shell electron, it releases the electron. This is the ejected electron. But when there is a vacancy created over here, electrons from the other shells come and fill those gaps. When they lose the energy, when they fall from a higher energy to a lower energy level, they will lose a photon. So those photons will be are characteristic because they are characteristic to a particular shell. So characteristic radiations are produced when they are falling from a particular shell to a lower energy shell. So like M shell to K shell, L shell to K shell, something like that. So a characteristic radiation is characteristic to the shell electrons. So that is how characteristic radiations are produced. Now coming to Bremmstrahlung radiation, these are also called as breaking radiation, or the break radiation. It's not break, it's this one. It's brake radiation. Brake, when we say with the vehicles, we are applying the brake, right? So electrons, they are coming from far with a higher energy like that. But when there is nucleus, nucleus will attract it toward themselves. So it is like applying kind of a brake to it, and when it's applying the brake to it, then it will kind of lose its energy. So some of its energy lost is released in the form of photons. Okay, so and the same thing, the same electrons which was coming very fast, which will lose, which was coming very fast, which will lose a little bit of energy, but it is still ejected with a lesser energy. So now this electron can form another Bremmstrahlung wave around another nucleus, but will release a lesser energy photon over there, and then it will come to a stop. It can either stop at this level also. So this electron can either be stopped at this level. This photon will have the same energy as that of the electron at that point. So the higher the energy of the electron, the higher energy of the photon that is released. So if you come to the angular distribution of the X-rays that is produced through that, so if there is lesser energy electrons, 100 keV electrons which are coming with that force, the photons produced due to those will have will be distributed in all kind of directions. So if you see, this is 0 degree, 30, 60, 90, 180, 270 and 360. So they are kind of distributed among all the directions if you see. So now as you increase the electron energy beam, so it is forwardly it is increasing. You can see it is increasing. If you increase it to 400 kV, it is increasing over here in one direction, forward direction. Okay, it is lesser over here. Now as you increase, if you increase 4 MeV, then you can see it is forward increasing in this direction, and it is lesser over in this direction. So what it means is it's just as the kinetic energy of the electron increases, the direction of the X-ray emission becomes more forward, increasingly forward. Okay. Now the photons that are released, so I said the photons are released based on the energy of the electrons which hit the target and then produce the photons, right? So those photons they will have both the Bremmstrahlung radiation photons produced, and they will have characteristic radiation also produced, Bremmstrahlung and characteristic radiation being produced. So now for lesser energy photons that are produced will have this is the relative intensity that is produced as per the energy level. So this is the photon energy. So this will be the curve for it. Now as you keep increasing the electron energy, the photon energy will also increases. So the photon energy will also increase, the intensity is increasing. They will have the characteristic radiation, some point at some point of the time the electrons will hit the inner shell electrons, right? At that time they will produce characteristic radiation. So most of these are, you know, Bremmstrahlung radiation. These are Bremmstrahlung radiation, but in between we have characteristic radiation. So as you increase the photon energy, they will have characteristic radiation at some point, and the intensity for those particular photon energies, as you increase the photon energy, these are the Bremmstrahlung and these are the characteristic radiation. This dotted is just unfiltered ones with, and the solid ones are just the filtered ones with the help of aluminum. That's it.